When you ask your phone a complex question, the intelligence answering you feels like it lives right there under the glass. But it doesn't. The actual thinking happens hundreds or thousands of miles away. To get an answer, your prompt travels to places like this. We are currently in the cloud AI era, where every query requires a data round trip to a massive, centralized server farm processing trillions of calculations before beaming the response back to you. That tether creates three structural bottlenecks. First is latency, the physical time wasted sending a signal back and forth across the country. Second is economics, with every cloud request acting as a tiny toll booth. But the third bottleneck is the most severe: privacy. If you use a cloud model to analyze medical symptoms or financial records, you're sending highly sensitive data across the internet to a remote server. The security vulnerability is built into the architecture itself. As long as every intelligent interaction requires this specific physical round trip, the current infrastructure remains a barrier to scaling AI to every device and every location. To eliminate the bottleneck, engineers realized they had to move the location of the computing. They had to take the intelligence out of the server farm and put it directly into your pocket. This triggered an intense engineering sprint known as the small model revolution. Researchers began figuring out how to compress production-grade language models so they could run locally on everyday hardware without losing their reasoning capabilities. In 2026, Google released the culmination of this effort, Gemma 4. It is a family of highly capable, open-weight AI models built specifically for on-device deployment. This shift redefines the boundary of compute. By downloading the model weights directly onto the device, the intelligence moves to the data, ensuring the information never has to leave the room to be processed. Just 3 years ago, the dominant logic in AI development was that making a model smarter required making it physically larger. Today, however, that correlation has completely collapsed. This chart shows the jump in the AIME 2026 math benchmark. The previous generation of on-device models scored around 20%. In a single generational leap, the Gemma 4 31 billion parameter model hit 89.2%. At the same time, the hardware footprint is shrinking rapidly. The smaller Gemma 4 E2B model is so efficient, it runs natively on something as minimal as a Raspberry Pi, a cheap, low-power circuit board. Intelligence in AI is no longer a metric of raw physical scale, but of architectural efficiency. Packing the vast knowledge of a supercomputer into the tight constraints of a mobile phone requires entirely new approaches to how neural networks are structured. Quantization crushes weights to 2 bits, squeezing the network into under 1.5 gigabytes. Mixture of Experts divides this model into over 100 specialized subclusters. By routing computation to just 8 experts per word, the network stays mostly dark, slashing required power while delivering top-tier reasoning. Because this architecture allows the AI to operate entirely offline, the security of your data is guaranteed by the laws of physics rather than a corporate privacy policy. By releasing Gemma 4 under the permissive Apache 2.0 open source license, Google removed the final barriers to enterprise adoption, allowing developers to build without usage caps or proprietary cloud fees. Developers are actively building zero-latency applications like on-device medical diagnostics and instant financial fraud detection, deploying them directly into regions where internet infrastructure doesn't even exist. And these isolated devices can still learn from each other through a process called federated learning. As you use the model, your phone calculates mathematical improvements, called gradients, and shares only those numbers with the broader network. Your personal files stay completely locked on your phone. This solves the central data paradox of modern computing. The global AI gets smarter by analyzing collective human behavior, yet every individual human retains absolute privacy. The combination of permissive licensing and localized learning turns individual hardware into a collective network that improves without centralizing user information. By the year 2030, industry analysts project there will be roughly 6 billion edge AI hardware units deployed worldwide. The mathematical reality is significant. Those 6 billion phones, tablets, and embedded processors hold more combined computing power than every traditional data center on Earth. The center of gravity for artificial intelligence is migrating into billions of pockets, forming a decentralized, private supercomputer that operates entirely at the edge.